Good afternoon, everyone. Welcome to the session on protect application data from disaster and ransomware with AWS. My name is Murtaza Chowdhury. I head the product management team for AWS data protection. And later, I will be joined by my colleague, Anar Anand, who is a senior product manager. Today, we're going to cover the importance of application data and the need for a centralized solution to protect your data. And then we will cover AWS capabilities using which you can put together a solution to protect your data against disaster or ransomware events. Every business relies on data. If you look at how data has grown over last few years, it has gone from half a zettabyte to 33 zettabyte in 2018, and it is projected to grow up to 181 zettabytes, which is more than 5x growth. So data powers businesses. Data helps you drive decisions. Data is the backbone of businesses, and there is a lot of data that is generated because most of the companies out there is a software company in some shape or form. And the importance of data protection comes in there. Data needs to be protected from data loss and data breaches. If you see some of the surveys, most of the events that have occurred against businesses have been on the data, have been on the site that host application data that customers deem critical. So customers are building strategies on how they can protect the data easily, reliably, and in a way that they can restore their applications, bring back their applications into a fully functional state. Let's look at the factors that can lead to a potential data loss or data breach. People who are familiar with disaster recovery as a paradigm in general, can I have a show of hands? All right, so you're most likely familiar with the first three cohorts here, which are disasters can happen due to natural reasons such as floods or earthquakes. It can happen because of a technical failure, maybe a software bug made into the system, maybe a regression that caused a failure in the application. It could be human error, and human error could be accidental deletion, or it could be malicious intent as well. But beyond these three factors, which are most widely known, there is a fourth category that is becoming prevalent, which is ransomware. So you need to have a strategy where you can not only protect your data from data loss, but also protect your data from data breaches. In terms of the disaster recovery approaches that you apply, you could have an active passive site, an active site, or you could have real-time data replication so that data and your application is has a fault-tolerant instance and can be failed over to. But in terms of ransomware, the strategies need to be tweaked a little bit. And we are going to talk about how you can think of them together, how you can have a combined strategy for disaster as well as ransomware and protect data, application data, as well as have recovery strategies from there. Let's dissect what a typical ransomware event looks like. I have heard from customers that by the time uh, in the unforeseen event of a ransomware note coming in, it's too late. In most cases, you would know when the note has arrived, and by then the data has been encrypted, or the data has been deleted, or data has been taken control of. But let's take a step back from there and see what has happened before that. So typically, for a ransomware event to occur, it comes in through points where which are not secure. It could be phishing, it could be weak software systems, it could be exposed through internet, uh, where uh, privileges are provided more than what it is required to run an application, and taking stock of the users who can run the application. And once such systems and such programs get access to your environment, they could activate the malware, and it could lie dormant for a long time, which could make it very hard for it to be detected. And by the time it gets activated and it takes control, it moves very fast. It moves very fast. It reaches other resources. There are lateral movements. There is spread, and there could be attacks on the primary data, which is powering the application. There could be attacks on the protected copies, whether they are replicas or backups. There could be encryption, and finally, uh, going back to where we started, the ransom note, which tells that it was a ransomware event. So while devising strategies to protect your data, it has to be an approach that takes all these factors into consideration. Let's understand what teams are involved. And these are some of the archetypes that customers have told us. And depending on how your organization is, you may have more than 4 teams or less than 4 teams, uh, but it's the duties and the responsibilities. Let's pay attention to those. So there is an application team who is responsible for building the software, building the application, making sure that the application is up and running, performing DevOps work, performing IT administration work. Then there is a data protection team who is centrally responsible for making sure that the data is protected. And the application team would tell the data protection team that, hey, these are the applications I care most about. And within the application, here are the tiers which make up the application. And if I have to run the application, I need the entire set of resources, or here are the minimum required tiers that I would need to run the application. The other team is the security team, which whose responsibility is to make sure that the security posture of your application is maintained. Continuous monitoring of your application, uh, detecting events, making sure there are responses applied, making sure that the environment is kept up to date. Like for example, if the security team detects that an instance is not patched, it doesn't have the latest security patches, or one of the response actions could be make sure the instance is up to date and make sure all other teams are aware. And then there is the compliance team who, depending on which industry vertical you are operating on or where your application is operating on, make sure that the regulatory needs are met. And there could be organizational processes as well, which needs to be enforced that the application team looks into. Now, while there are separation of duties, these teams work together in a coordinated way to make sure that the application is protected, the application is up and running, and their goals are to have as high as uptime as possible, minimize downtime, and prevent data loss completely or minimize it to whatever extent they could do. So those are the shared goals, and the business is backed up by the application data, and all these teams work together to achieve those results. Now, let's understand when we say application, what it's made up of. Now, application could have very different definitions to different people. You could think of it as the entire topology, which includes the different resources across cloud, on-premises, and the edge. It could include the user data that your end users are generating, or the data that is part of the system itself for it to maintain the state and run the system. There could be permissions, which tell who has least privilege access, what type of roles should be allowed, how they access the system, and what they can do. And there are network configurations, as in which resource talks to other resource in which way. There are also dependencies in if you have to bring back the application, which should go first, which should go later, and in what order. So AWS, most of you should be familiar with this. There's a shared responsibility model in terms of protection and security and compliance, where AWS is responsible for security of the cloud, and our customers are responsible for security in the cloud. What this means is that durability, resiliency of the infrastructure and the software that AWS deploys, they offer durability, they offer SLAs, and for the things that the customer is responsible for, there are tools, there are services, there are primitives, there are management solutions that are available that you as a customer can leverage to make sure that you can meet your share of the responsibility. And we will talk about what different types of tools are available and how you can use them together to make sure that your application data remains protected and you are able to recover in the case of an event like that. So we looked at things which are the teams. We looked at what could be a composition of an application, and we looked at the shared responsibility model. So protecting application data, it is a function of all three. It is a function of the teams, the people, having the right organization culture and making sure that people are aware and that take a proactive approach to protecting their applications and making sure that they can recover them. Understanding the technology, understanding the applications well, understanding how the applications can be protected, how they can be recovered, what are the dependencies, what are the most important parts of the application that are needed to run the business. And finally, the understanding the tools that AWS offers. And if you're using resources outside of AWS, how they work together with each other. So with that, I'm going to invite on stage my colleague Anar, who's going to talk about the strategy for protecting application data.
Thank you so much, Murtaza. Everybody hear me? Awesome. Well, that really does set the stage for how we're going to approach our data protection strategies and protecting our application data. But just another show of hands, how many folks have already implemented something like this in your organizations? Great. A few of us. Awesome. Well, you know, if we need a strategy that fits all of our applications, we'll know that not every application is created equal. Not all data is created equal. So we need something that can scale, that we can customize, and that we can repeat for multiple applications in our organization. The National Institute of Standards and Technology provides us a simple framework that we can use to implement these strategies across our organization. And there's 5 simple pillars, if you will. For those of us not familiar with it, I'll just set up a baseline here. The first thing you do is identify your critical workloads. Now, what is a critical workload? I've been a business owner myself, and years ago, if somebody had asked me, what is the most important data you want to protect? I would have said everything, right? Everything's critical. If any one application's down, the whole business is down. Is that really true? Is that how applications can work? If we try to recover everything, if we have a golden copy of everything, we're probably saving our cat videos the same as we're saving our most critical databases. So when we identify our most critical workloads, what do we mean by that? We need to know what data, if rendered unusable, inaccessible, or corrupted for any reason whatsoever, is going to create downtime for our business or create some way, shape, or form damage to our business. So we'll keep that as business critical workloads. Now that we know what those business critical applications are, we need to protect them. So we apply different types of safeguards necessary to our applications depending on what. We'll need to have some sort of mechanisms there to understand. So what is an acceptable protection mechanism for your application? We'll come back to that in a minute. The third pillar is detect. Once you have some protection mechanisms in place, you'll need to monitor them. And once you have all of that in place, you'll respond and recover your applications in case of that unforeseen break glass scenario. So we have a few questions there. When you form your strategy, you ask, well, should the recovery of some data be prioritized over others? We have one example. Cat video is probably not the most important, but my transaction data, probably more important. What is an acceptable recovery time? What's an acceptable recovery point? These are some very critical considerations as you consider your data protection strategy. How much data can you afford to recreate or lose? Remember, we talked about the business critical applications. Each application will have a different type of implication to your business. And based on that, as you create those protection mechanisms, such as your backup plans or your snapshots, your replications, your network configurations, you'll think about how far back in time would you like to go in that time machine of yours. The other part of it is the time. As Murtaza mentioned, data is growing. It's growing exponentially. Trillions and trillions of gigabytes are now something that you are managing. So can we have a one-size-fits-all recovery time objective? Not at the moment. So we'll need to consider the downtime, data loss, how quickly you must recover, and what you want to recover first. We want to protect our application not just in one way, but we want multiple levels of protection there. In your house, you lock your windows and doors, yet you still want your blinds and curtains so that no one can look in. You have those protections, and yet you'll have a security system, cameras all around the outside, and maybe even a German Shepherd, just to be sure. The same way, we want to ensure that our applications are protected in multiple ways to make sure that our surfaces are all protected. We want to create a scalable permissions model. We have a lot of users using these applications. And so you'll want IAM policies, identity and access management policies in place that will ensure that the right people have access to the right data at the right time. Many of our healthcare friends know PHI, sensitive data in financial industries, retail industries. Access policies need to be maintained so that we can really restrict to the least privileged user. We want to use our security controls to keep that perimeter secure. And as you create your backup and restore and recovery strategy, the frequency of your backup plans, the replicas, your cross-region and cross-account strategies based on those RPOs and RTOs that you thought about earlier will come into play. So let's tie it all together with a little bit of a defense in depth analogy. Your first line of defense is focused on the identity and access management, which forms a trust radius for the customer. So, for example, providing multi-factor authentication tokens that deny potential attackers access to your organization. Murtaza mentioned the ransomware events, if you recall. The second line of defense is the automated monitoring of your security perimeter. In case an attacker breaches your perimeter, be that your VPC, your accounts, your organization, you'll want to automate that monitoring so that you can scale your protection. Our customers tell us that they want to monitor resource configurations and know when someone changes something in the environment, such as a KMS key, or when their resources and metadata matches patterns that are indicators of ransomware events. It could also include mechanisms that provide time delays for organizations to react to anomalous behavior and usage patterns. And then the last line of defense focuses on secure backup storage and achieving restore RTOs in the cloud and on premises. Controls such as cross-region and cross-account strategies for your management, and active auditing and alerting of your protection policies help you to be compliant and add that additional layer of protection for ransomware. So these approaches can come together and be used to help you build your own defense in depth strategy. Okay, so we identified our critical workloads. We added protection to it. Now we need to monitor this and make sure that everything is secure as we want it to be. AWS provides a few services that can help you monitor and automate the monitoring of your backup strategies, your protection mechanisms, as well as stay in compliance with auditor-ready reports. Audit trails are an important part in understanding who is accessing your data, when they're accessing it, how they're accessing it. You want to be able to scan for malware, any new additional signatures that have come into play since your last scan. So you want to do this on a periodic basis. And then, of course, there's anomaly detection. We have privileged users who may have their credentials compromised. And we want to know these things early and often. Now, as we think about our recovery approach, a lot of you mentioned that you're familiar with disaster recovery practices. And we have a few known knowns there. We think about things like earthquakes and floods and fires, maybe a region going down. In all these cases, you're recovering your data. Now, as we think about ransomware situations and other unknowns that may come up, we're not only thinking about recovering the data, but making sure that that data is usable when it is restored. So a big thing that comes into play here is a data immutability strategy. With features such as AWS Backup Vault Lock, Amazon S3 buckets, and S3 Object Lock, many of our customers will be familiar with these things as they employ a write once, read many, or a worm strategy to make sure that their data is protected immutably, as well as applying those extra delete protection policies to their backups and their S3 buckets. So we've gone through a few steps of our framework. We've gone through identifying our critical workloads, we've protected them, we're monitoring them. Now, in case that disaster strikes, or you come into that break glass scenario, are you confident that you can recover? How often do you test your strategies? Anyone? Not so very often, it seems. Recovery is only as valuable as the protection that you've proven that you can do. So it's important to set up a sandbox environment. You want to verify that the RTOs and RPOs that you've had early on when you identify those critical workloads are still the same. Data is changing, so so can the size of your data, which can affect your RTOs. You want to be able to test those consistently and make sure that you're arriving at a similar goal that you can actually recover from. So when your boss or your manager or the business owner says, my application's down, you can say, I know I can recover that because I've already tested it. You can minimize your application downtime because you can show a report. This is done, this is verified. Let me flip it back over to Murtaza now to apply all of these protections to a simple everyday application.
Thank you, Anar. All right. So we are going to look at the methodology that Anar talked about into how we would go about protecting your application. So let's do a quick recap of what she covered. So first thing is you need to define a protection strategy, taking into consideration what kind of RPO and RTO you would like and you would expect out of the system. RPO is the amount of data loss that you can tolerate, and RTO is the amount of downtime you can tolerate. So you want to minimize both of them. So you want to choose your mechanisms of protection in a way that they are conducive to the application, they're conducive to the resources that make up the application, and they're conducive to the objectives that you have. Once you do that, the next step is how do you go about detecting what's happening in your environment. So you would leverage AWS services such as guard duty and other services that can scan for malware and tell you if there is an event, or you can use any software that you use from ISVs. And when that happens, you would remember the 4 teams that we talked about, the application team, the data protection team, the security team, and the compliance team. If such an event happens, the security team would come in, they would investigate, and the data protection team may work with the security team to decide that they want to bring back the application because they have the RTO goal. And the way they would do it is to devise the recovery process based on the protection mechanisms that they have set up. And to gain confidence in the recovery process, they would test out the recovery in different accounts, different regions, with different combinations of what are the most important parts of the application or the entire application as a whole. And if there is an event, the verified recovery process that you can kick off so that you can bring back your application. You can test out whether the application is working at a production site or not, and start bring back your business. Now let's look at what happened. The example that we have here. So we have a 3-tier application, which consists of EC2 instances, which are taking the user load. It uses a database with RDS, which is storing the stateful data. Going back to the shared responsibility model, there are security that AWS takes care of, and there are things that customer as you have to take care. So AWS provides security for the infrastructure, for the patching of the systems, and for the managed solutions. And if it is an EC2 instance, it's an infrastructure as a service. In that case, you as a customer are responsible to make sure that it's patched and it has the latest instance. So you would figure out what kind of protection mechanisms you would apply here. So in this case, most of the stateful data is in EBS volumes. So you have multiple options with you. You could create snapshots and you could define the periodicity in which you want to create the snapshots. You could use a product such as Amazon Elastic Disaster Recovery Service, which keeps a real-time active site which you can use to failover. Or you can use immutable backups, which a service like AWS Backup that preserves immutable copy of the data. We talked about how disaster recovery in general and how ransomware protection can be different. And key pieces that are different there is immutability, to make sure that the data that is kept protected cannot be tampered with. And the other thing is how you make sure that your recovery processes are verified and your data that you have, both in the application as well as the protected copy, are scanned for malware, both at the time of keeping the protected copy as well as bringing them back when you are restoring and recovering the application. So you would have the detection mechanisms, and you would create recovery processes that you would test and you would gain confidence on, and you would run them in the defined periodicity, and that's where the compliance goals come in. So depending on what industry you operate in, what sector you operate in, what are your organizational processes, you would define the compliance goals that that you would take into account when you are testing the recovery state, and also making sure that you have the right protection mechanisms. And to bring back the application, so as you can see, there is a multi-AZ sync replication happening in the RDS database. So if this is a natural calamity like a flood or earthquake, it could fail over to the other availability zone. But if it is a ransomware, then it could have impacted the stateful data that is there. So it needs to be protected in an immutable store. So for such a scenario, what you would do is you would use a service such as AWS Backup, which offers the immutability, which can protect both the EC2 instance as well as the RDS instance in a secure vault that is immutable, with separate access policy, with separation of concerns, and you can look at the desired RPO and RTO. And while you are testing the recovery and restore process, you can make sure that they are maintained. And if there is a disaster event, and if you have detected that there is no malware, you can choose the replicated copy that is either in a snapshot, which may or may not be, which is kept created in a periodicity, and or the DRS based snapshot, which is active site. It is a replica, and a replica is maintained whenever there is a read or write detected in the instance itself. You could use that, or if you detect that there was a malware event that your detection systems used, then you would use the immutable backup. You would use the immutable backup to bring your application back, given you have tested your recovery process. So with that, I'd like to talk about the key takeaways. So we started with protecting your application data, and it is a function of people, technology, and shared responsibility. The teams that are involved, the application team, the data protection team, the security team, the compliance team, they have separation of concerns, but they need to work in a coordinated way so that they can fulfill the RPO, RTO, and the recovery needs that the organization has. Second is baselining the considerations. Baselining the considerations based on the trade-offs you could have. There could be cost considerations, there could be data considerations where you decide what kind of RPO and RTO you would have. Whether you want hot, warm, or cold site for your recovery, that will be based on what kind of objectives you have there. And finally, once you have set up the recovery protection mechanisms and the recovery processes, how do you gain confidence in that? And you do that through repeatedly testing it, repeatedly tuning your environmental goals, and making sure that you are able to bring back your application and within the goals that are within the regulatory boundaries or within the organizationally enforced boundaries. And if you do these things, you should be able to recover your application and gain confidence in the process and bring your application back, whether it is a disaster event or a ransomware event. So I'd like to thank you, and we have our email IDs here. If you have any questions, and if you have any suggestions, feedback for us that you want us to consider in terms of capabilities, you can email us. We'll get in touch with you, and we'll take the discussion forward. And I hope you found the session valuable. So please don't forget to put in your session survey. Thank you so much.